Okay, and so today on probability, we're looking at conditional probability. So the chances of one thing happening given another thing has already happened. Okay, so we're going to look today at conditional probability, and that's basically the probability, or something like what are the chances, which is just regular probability, that A will happen, the probability of A, that A will happen given something else already having happened, given the fact, or given that B has already happened. So for example, one of the questions might be has already happened. So an example might be something like, what are the chances that school will be closed given the snow that we've been having, etc. Or what are the chances that school will open, or what are the chances that the leaving cert will happen given the COVID-19. Okay, so that's conditional probability, and basically it's generally written something like this. So P of A given B, so this line here means given, and that's calculated basically by the number of elements, the cardinal number of A intersection B all over the number of elements of B. And I'm sure that's just the same thing as writing the probability of A intersection B over the total probability of B. Okay, so that's and just to note here, I suppose, the B on the right hand side, the B is on the bottom. Okay, and so also P of A given B, I'm just gonna group that. So the condition of one thing happening based on the other does not equal vice versa. So P of A given B, it's something we'll explore later, but we know it from life anyway that the opposite or vice versa isn't always true here. So we need to put a big black line through that equals. Okay, so that's one fact for us. So the condition, or the chances of A happening given that B has already happened, does not equal the chances of B happening given that A has already happened. Okay, so but here this is our big definition for it, and so make sure that you get that taken down, and then we'll do a couple of examples together. Okay, so here in this question we're told that a couple have 3 children. Find the probability that all 3 are girls given that at least one is a girl. So, well, the family could look something like this without any conditions on it. You could have one girl born, then another girl, and then another girl, so it's all girls. You could have a girl born, then a boy, and then another girl. You could have a girl born, another girl born, and then a boy. You could also have a girl born first, and 2 boys born, so a boy and then a boy. You could have, you could have a boy born first, then a girl, then another girl. You could have a boy born first, then a girl, then a boy. You could have a boy, then a boy. Oops, no need for another comma. A boy, boy, and then a girl, and then you could have, the last option would have been to have 3 boys born. Okay, so that would be what the family could look like. So they're all possibilities. But we're asked, so in this case, to find the probability that all 3 are girls. So that's, we're going to call A here, where it's G, 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 given the fact that there is at least one girl. Well, so B is our sample space with at least one girl. So what is B? B is this situation, this, this, and this one. So the only one that's left out. So just to rewrite those, I have G, G, G. Okay, and so we want to work out here the probability of A given B. And well, we know that that is equal to the number of elements of A over of A intersection B over the number of elements of B. So that's going to be equal to, well, our number of elements of A intersection B is 1, just this one here. And that is going to be over a total, how many have we got in here in B? 2, 3, 4, 5, 6, 7. So our answer is going to be 1/7. Okay, and that's it here. Okay, so we'll have another look at another example. Okay, so here we're given a Venn diagram and we're asked to find the probability of x given y and the probability of y given x, and it's something just we discussed a moment ago. Okay, so here we go. We want to find p of x given y. So p of x given y is equal to, well, the probability of x intersection y all over the probability of y. So that's going to be equal to, in this case, well, the intersection is 0.2 and the probability of all of y, so we can't forget to add the two together, is 0.1 plus 0.2, which is 0.3. So when we work that out or multiply across to get rid of our decimals, that's a probability of 2/3. Okay. And so similarly then, so P of y given x is going to be the probability of y intersection x all over the probability of x. Okay, and so here, well, the intersection remains the same, it's 0.2, and all of x is 0.3 plus 0.2, which is 0.5, multiply top and bottom by 10 to get rid of our decimals, and that gives us 2/5. So here we can see very clearly, just like we said before, that one condition does not necessarily equal the other condition, the chances of it happening. Okay, they could equal, but they don't necessarily. Okay, so here we're given a question. We're told x and y are two events such that the probability of x is this, the probability of y, and we're told the probability of x union y. So we're first asked to find the intersection. Well, so this is just a general set issue really first. So if I draw my little Venn diagram here, and so here I have x and here I have y. Okay, so I know that all of x is equal to 0.4. I know all of y is equal to 0.3. I know what the total of the three of them are equal to, the 3 bits here, but I don't know this bit here. So what would I do? Well, I know that p of x union y is equal to p of x plus p of y, and I always remove the intersection or take it away because I don't want it to be double counted. So here I have 0.5 is equal to 0.4 plus 0.3 minus p of x intersection y. So just tidying that up, and that gives us 0.5 is equal to 0.7 minus p of x intersection y, and so remove the 0.7 from both sides, they cancel, and we have minus 0.2 is equal to minus p of x intersection y, and so that the intersection then is very clearly equal to 0.2. So 0.2 is equal to the probability of x intersection y. Okay, so that's solved. Okay, so this is a good little bit of revision on sets anyway for us, considering they're so much overlapped. And just for those who didn't do sets previously at Junior Cert, this obviously the whole rectangle is the universe. So I can say hashtag U. well, that would be 1 in this case. So I can see here, if this and this and this all add up to 0.5, then 0.5 is this space out here in outer space, because obviously everything needs to add up together. So we had worked out that our intersection here is 0.2. I'm going to just write that bit in here. So to work out what x is on its own, it would be 0.4 minus 0.2, which is of course 0.2. And likewise over here I have 0.3 minus the 0.2, which gives me 0.1, and I can see 2 and 2 is 1 is 5, so 0.5, which is what we were told. Okay, so that's just a little revision of our set theory from junior cycle. Okay, so now let's very quickly do part 2, which is find P of x given y. Well, we know that that's equal to the number of elements, or indeed just the probability of x intersection y over the probability of y, which we have here. Well, the intersection is 0.2. Again, y, the probability of it, is equal to the whole of it, so that's 0.3. And so our answer then, multiplying top and bottom by 10 to get rid of the decimals, is 2/3. Okay. Okay, and so one final example for us. It says in a certain country there's only 2 parties, the Red Party and the Blue Party. In elections, 60% of the votes was red, so P of R is equal to 0.6, and P of blue is 1 minus 0.6, or if I continue reading, 40%, which is 0.4. Now, of the red supporters, 70% favour disarmament, and of blue supporters 10%. So here we have P of disarmament, dis A, is equal to, well, it's 70% of red, so 70% of means multiplied by, and red is 0.6, plus 10% of, again meaning multiplied by 0.4, which gives us an answer there of 0.42 plus 0.04, which is an answer of 0.46. Okay, so that's the first bit. Then a voter is chosen at random and announces that she favours disarmament. What is the probability that she supports the blue party? So what are we looking for here? We're looking for the probability that she has a supporter of the blue party given she has voted for disarmament. Okay, so that's going to be equal to probability of B intersection D all over the probability of D. Okay, so that's equal to, well, B intersection D, we hadn't worked out on its own, well, we have actually, but anyway, just to write it down here, is 10% of 0.4, which was 0.04. So back over to here, we can fill in our 0.04 all over our 0.46. And so dividing those out, we get 2 over 23, and that's P of B given D. So that's all our examples, but just really to remember that the thing that comes second is always the probability that's on the bottom. And here, just to reread again, so it says, what's the probability that she supports the blue party? So that's the blue party given the disarmament. Okay, so it's just really important that we get our order correct here. All right, so get all of those taken down and then have a look at Schoology.